All right, this is the Algebra 1, new Unit 7, Lesson 2 video over the properties of exponents, specifically the multiplication and division properties of exponents. So I'm going to run through the different properties briefly and then do some example problems to go along with what you see in the unit. So I'm going to kind of explain how these properties work, but the first one we'll call the multiplication property of exponents. The multiplication property of exponents says that when I have two numbers with exponents, they have the same base. In other words, they both have a base here of a. Whenever I have this situation, I can do a little shortcut because, and I'm going to show the explanation and then explain kind of the rule. So because we know that a to the third is a times a times a, and we know that a to the fourth is a times a times a times a 4 times, then if I multiply all of those, then at the end I'm going to have 5, 6, 7 a's. So what we see is that when we multiply numbers with exponents, as long as they have the same base, I know that what's going to end up happening is I'm going to add the exponents to get the final answer. So I'm illustrating for you what's happening in the background, but we can just take this and immediately say, well, we know that's going to be a to the 3 plus 4 power, or a to the 7th, which you see here is what we got when we worked it out all the way. So basically what it means is that anytime numbers have the same base, the exponents can be added together when those two numbers are being multiplied. Okay, so this is when you're multiplying numbers with exponents. Okay, the next one we have is the division property of exponents. Okay, so the division property of exponents says, a similar way, when I have two numbers that are being divided that have exponents, I can subtract. And I'm going to explain how this works. We know that this is x times itself 8 times. 1, 2, 3, 4, 5, 6, 7, 8. And we have x times itself 5 times down here. So we know that when that happens, these 5 x's, for instance, are going to cancel out. Probably could have written that differently so that one wasn't dangling over here. So let me actually go back real quick. We know that these x's are going to cancel each other out, leaving me with x to the third. And so we know that really what we can do is we can do x to the 8 minus 5, and that will give us the same answer as we got up there. So what we're saying is when we divide numbers with exponents, we can subtract the exponents to get the final answer. So that's the product of powers property. And then we have the power of a power of a power. We'll talk about this one. This is a similar idea to the two we just got done doing. We know that when we have, for instance, we'll call this the power of powers. Power of powers says that if I have, for instance, c to the 4th raised to the 3rd power, then we know what that really means is to do c to the 4th times c to the 4th times c to the 4th. And I could even expand that further to say this is c times c times c times c. And this one is c times c times c times c. And this one is c times c times c times c. But we already learned a rule for how to do this right here. We know we're going to add 4, 4, and 4. But just so you can see visually, what this actually means is that I've got 12 c's. So we know that this means it's c to the 12th power. And the rule, what it ends up becoming is that when we have a power of powers, we can do multiply those two, and that gives us c to the 12th. So when you have a power of powers, you multiply the exponents. All right. We also have some rules about when we can kind of, in a sense, distribute the exponent inside of parentheses. So we'll call this distribution of powers. Now, when we say distribution of powers, we're talking about a situation where I have two things that are being multiplied by each other with an exponent outside of those parentheses. Multiplication and division only. So I'll show both. Let's say I have a divided by b raised to the 4th power. So in both of these cases, because of the distribution of powers, I am able to, again, only when we have multiplication or division, not addition or subtraction. In a sense, this 3 gets applied to both. So this becomes x to the 3rd, y to the 3rd. Similarly, down here, this 4 gets distributed to both. So it becomes a to the 4th over b to the 4th. And this could be combined into one big expression. Like even if I had something like this, x, y divided by b, all raised to the 4th power. Well, if that happened, again, I can distribute that 4 to every thing that's being multiplied or divided. So it'd be x to the 4th, y to the 4th, over b to the 4th. And you can see that 4 gets distributed to everything. All right. So those are all the properties they introduced. So from here, we're just going to, and there's a summary of the properties in the lesson, but I already posted a document for you that has all the properties listed. So I'm going to work through a set of problems, and they are basically 15 problems to match the 15 problems you have on your lesson. So let me jump over to that. So I'm going to work through these and just explain kind of the solutions to each one. And you need to use these as your guide to solving the problems in the lesson itself. All right, so jumping right in, we have, in our first problem, we have 3 raised to the 4th and 3 raised to the 2nd. So we know that based on our rule, if the bases are the same, we can do 3 to the 4 plus 2, or in other words, 3 to the 6th. And then we can find what 3 to the 6th is. 3 raised to the 6th power. I want you to see what I use there. When I did that, I used this button here. So I did 3 raised to the 6th power, and we get 729. And so that would be the answer for that. But the key here is that you got through to this using the property. Number 2, okay, we're multiplying numbers. We have some constants. We have a couple of b terms. So we're going to organize this. We're going to multiply the 2 and the 5 together. That's going to be its own thing. And then we're going to multiply the b's together. And that's going to be its own thing. And when we do that, we get 10. And then b, because these are multiplied, we add the exponent numbers. 3 plus 4 is b to the 7th. So that's how you're going to be using those properties here. Okay, number 3 is really straightforward. Just making sure you're paying attention to the rule. Remember, the rule says when numbers are multiplied, when the exponents are being multiplied, we add the exponent numbers, and so this becomes x to the 9th. Pretty easy on that one. Number 4 is just again adding more complexity, but don't let this throw you off. You still are going to multiply things that are alike. So we're gonna put the 3 and 6 together. I'm going to put my x's together. I'm going to put my y's together. So I've kind of organized this again, and so when I do that, I get 18. This becomes x to the 7th because 4 plus 3 is 7. And this becomes y to the 3rd because y to the 1st, there's an imaginary 1 there. And y squared gives us y to the 3rd. All right. Number 5 is doing the multiplication of powers, or power of powers. So this looks like the following. 2 to the 3rd times 2 times 4. So when we raise a power to a power, we multiply those powers. So this becomes 2 to the 3 times 2 is 6. 6 times 4 is 24. And I'll tell you right now, that's going to be a really big number. That's okay. We'll do 2 raised to the 24th power. It's a super big number. I'm assuming the one on the test is not quite as crazy as that one, but we'll just 16,777,216. But you get the idea. The point here is you need to multiply the powers as you go through. Number 6 introduces the distribution of powers. So we're distributing this 2. It's going to go to both of these, and you'll see what happens with the b is something interesting. So it's going to be a squared, and then it's going to be b to the 4th squared. So that's going to, the a squared is going to stay the same, but the b is going to be power of powers. So it's going to be b, 4 times 2 is 8. So you see how we're starting to combine the properties together, using them in conjunction with each other. And that's kind of what happened there with the b to the 4th squared. Same thing with number 7. So we're going to go through. We're going to do negative 3 to the 3rd power, x to the 4th to the 3rd power, y squared to the 3rd power, and z to the 3rd power. So notice that that 3 got multiplied to every term in there. Negative 3 to the 3rd, you can do this in your calculator, but the answer is negative 27. 4 times 3 is x to the 12th. 2 times 3 is y to the 6th. Z to the 3rd. So again, you just follow the process, doing each property on its own, and it should work out pretty well. More of the same here. I'm distributing this to 4 squared, a to the 7th squared, b to the 6th squared. 4 squared is 16. Use your calculator if you need to. 7 times 2, that's a to the 14th. 6 times 2, that's b to the 12th. So the more familiar you can be with the properties, the easier these are going to become. You won't have to keep flipping back and forth. Just remember, power of powers means multiply. Okay, this one can get a bit crazy. We'll work from the inside out. So we're going to leave this. We're going to leave this out here with the 4 on it. Let's shrink that down a little bit. There we go. So we're inside here. We're going to have negative a to the 3rd, or we're going to make that negative into a negative 1. So it's going to be negative 1 squared, a to the 3rd squared, b squared squared. So notice we're distributing this 2 to everything. We get inside the brackets, we get negative 1 squared, it's just 1, so we don't really need to write that, but we will. A to the 6th, b to the 4th. I'm going to rewrite this. Or no, we don't need to rewrite it. We'll go to the next part, which is to take this 4 and distribute it to everything. We don't really need to do the 1, because 1 to the 4th is 1. But I'll write it anyway. So we have 1 to the 4th, a to the 6th to the 4th, and b to the 4th to the 4th. That's going to be, we're going to go ahead and get rid of the 1 to the 4th now. So we got a to the 24th, because 6 times 4 is 24, and b to the 16th. Number 10, just again, like more of the same kind of stuff happening here. We ended up with some negatives though, but we'll deal with that as we get closer to the end of the problem. We have 3x to the negative 2. Down here, this 2 is going to get distributed. So we're going to have x to the negative 2 squared and y to the 3rd squared. The 3x minus 2 is going to stay. X to the negative 2 times 2 is x to the negative 4th. Y to the 3rd to the 2nd is y to the 6th. Because these are negative exponents, they need to be moved to the other side. So this becomes 3x to the 4th, because that 4 went up and became positive. X squared went down here, y to the 6th. Almost done. The very last step is to deal with the fact that we have 2 different x's. There's 4 up here and 2 down here, so we're going to do 3x to the 4 minus 2 is x squared, and then the y to the 6th stays in the denominator. That's probably the most challenging one so far. Just remember the negatives. You got to switch them from one side of the fraction bar to the other in order to get the final answer. Then they have us calculate the value. What they mean they want you to do is they want you to take these numbers and replace b and a with them in the problem. So we're going to run through the entire problem and replace them. So a to the third is 3 to the third over 3 to the fourth plus 3 over 2 to the negative 2 power. So we're going to start working this stuff out. 3 to the third is 27. 3 to the fourth is 81. 3 over 2 to the negative 2. Well, that means it's going to be 3 to the negative 2 and 2 to the negative 2. So 27 and 81 are going to stay there. Because these are negative exponents, they need to switch sides. So we get 2 squared and 3 squared. I'm going to bring that around here. So we have 27 over 81 plus 4 over 9. And so then we're going to work that out. 27 over 81. 27 divided by 81 plus, that was 4 over 9. 4 divided by 9. We convert that to a fraction. It's 7 over 9. So you just rely on your calculator for that. So just be aware on that. All right. So we rewrite that 3 there. More of the same. We're going to plug in 2 for everything throughout the problem. We're going to plug in 2 for all the m's. So it's going to be 2 to the third minus 2 squared plus 2 to the third times 2 squared. Start working all that out. 2 to the third is 8 minus 4 squared plus 8 times 4. Keep working it out. 8 minus 16 plus 8 times 4 is 32. 8 minus 16 plus 32. That one's pretty simple. 8 minus 16 plus 32 is 24. And that's the final answer there. All right, the next problem introduces just a kind of word problem, but really this is the same type of problem, just kind of disguised as a word problem. They're telling us the radius of the formula for the circle is this. So we're going to take that and we're going to plug it in for the r in this formula. So we're going to say the area equals pi r, which is 4x squared y squared. And so it turns into a property, exponent property problem. That 2 is going to be distributed. So it's going to be pi 4 squared, x squared, squared, and y squared. Really need that. So we're multiplying all those things together. 4 squared is 16, and we're going to put the pi right next to that number. X squared squared is x to the fourth, y squared. Now, I actually think the best order to write this is going to be the following: 6 x to the fourth, y squared, the pi at the very end. So really, don't let the pi throw you off. You're not really going to do anything with it. You just need to simplify the exponent portion of that problem. And so there would be our answer there. More of the same here. They're giving us a value for r and a value for h. So we're going to take those and plug them in here. So it's going to look like this. Volume equals pi, and then we're going to have r squared, which is 3x squared times 4xy to the third. We go on to the next step. 3x squared, that 2 is going to get distributed. So we're going to get 3 squared x squared, 4x y to the third. We need to organize that so we can get things that go together. That 3 squared is going to become 9. Then we'll have the 4. Then we'll have the x squared and the x and the y and the pi. So all I've done is just reorganized all of this into this order, and then we multiply everything together. 9 times 4 is 36. X to the third, because 2 plus 1 is 3, y, and then pi. All right, and then we're on to our last problem. So lots of negative exponents here. Let's go ahead and deal with all of the negative exponents at the very beginning of the problem. So we're going to move everything around. We're going to move this down here. We're going to move this up here, and then we'll see what we get. 4 is going to stay. Y to the fourth is there. z moved up, z squared. On the bottom, we have 20. We have x squared, and then we also brought down an x to the third. And then the y to the third is there as well. We start canceling things out. I can see right away that I'm going to cancel out all of these y's, and 3 of those are going to go away, leaving me with 1. 4 and 20 are both divisible by 4. 4 goes down to 1, 20 goes down to 5. So we're going to have on the top, we're going to have y to the 1, z squared. 5 on the bottom. X squared and x to the third make x to the fifth because we add the exponents, and that y canceled out. And so that is the final answer. So again, that one puts together a lot of the properties all in one. All right, so that was a lot, but hopefully each of these example problems will help you along your way. Reach out to me if you have questions. That's the end of the video for lesson 2.